Hello everyone, my name is Subhanshu Raj and I am your chemistry faculty, and in today's class we are going to see a very important naming reaction, and that is nothing but the Gabriel thalamide synthesis of primary alkylamine. Okay, so this is a very useful and very important reaction. Why I am saying this is very important reaction? Because in the last class we saw that how to prepare amine. Okay, so in last class we saw that if we have a alkyl halide and that alkyl halide is going to react with ammonia, it will going to form your amine. But again, when you have a more alkyl halide, again it will going to react, again it will going to give you a secondary amine. Again you have alkyl halide, again it will going to react with ammonia, and again it will give you a tertiary amine, and so on. So my question is that you are getting alkyl amine, but you are not getting a 1 degree amine in pure form. So then this naming reaction, that means the Gabriel synthesis reaction, is coming to the picture, because in Gabriel synthesis you will get a pure alkyl amine without contamination of 2 and 3 degree amine. This is the beauty of this particular naming reaction. So without wasting the time, let us start the Gabriel synthesis. So our today's topic is the Gabriel synthesis of primary alkyl amine. Okay, so first of all we will see in one shot what is this reaction all about, and after that we will see the mechanism as well, and in last we will see some questions as well. Okay, so what is the Gabriel synthesis of primary alkylamine here, in which we are going to see alkyl halide are going to convert it into alkylamine. Okay, so here your alkyl halide is converted into alkyl amines, especially 1 degree amine we are going to use without contamination of 2 and 3 degree amine. So this is the beauty of this reaction. Okay, one more thing which I want to tell, that the key reagent of this reaction is your potassium salt of the key reagent of this reaction is the N-potassiothalamide. Okay, I will tell why this is acting as your key reagent in this reaction. So first of all, what is this reaction all about? Let us write here in one shot. The reaction is nothing but you have a thalamide. So I hope everyone you know what is the structure of thalamide. If you don't know, let us see. You know what is ammonia. In ammonia you have 3 hydrogen. When your 2 hydrogen is replaced by 2 carbonyl group, if you can see here, this is nitrogen, there is 1 hydrogen is present here, but 2 hydrogen is replaced by this carbonyl group. So this is called as imide, and the proper name is called as thalamide, PHTHAL, and here you write IMIDE. This is called as imide. So this is the whole structure is called as thalamide. Okay, so first of all we will going to take a thalamide, and this thalamide, first it will react with KOH. We are going to take potassium hydroxide. The second one, after whatever we will get, we will see. The second one is going to react with your alkyl halide. So I am taking a CH3Br. Okay. The third one which we will see is the hydrolysis. We will see acidic hydrolysis as well, we will see basic hydrolysis as well, and we will see what will happen if I will take N2H4. That means what will happen when you will take hydrazine. N2H4 is nothing but hydrazine. Okay, N2H4. So let us see, student, if you have a thalamide and if you have this all reagent, then what will you get? You will get CH3 NH2. As I already told that you will get 1 degree amine, and that 1 degree amine, and after that what will be the byproduct? That will be the main question, and that will depend upon what hydrolysis you have taken here. So if you will take H2H plus, you will get phthalic acid. You will get phthalic acid. Okay, but if you will take N2H4, you will get thalahydrazine. You will get this structure. Very important. Thalahydrazine. This structure is called as thalahydrazine. So when you will take H2H plus, the byproduct you will get phthalic acid, and when you will take N2H4, you will get thalahydrazine. But your main product will remain same. Means you will always get CH3NH2. This will not going to affect your product. Okay. So this is in one short. If you ask what is Gabriel's synthesis, then your phthalimide is going to react with KOH. It means first it will do the acid-base reaction, and after acid-base reaction you will get a very beautiful nucleophile, and that nucleophile is going to react with CH3Br, and after that whatever the product you will get, when you will do the hydrolysis, you will get your CH3NH2. Okay, so let us see the mechanism. So I am just erasing this part, and you will see the mechanism. I hope everyone noted this all point. So if you will see, first of all I will take phthalimide. So here this is called as phthalimide. Okay, this is your phthalimide. First what we take here, KOH, OH minus. Okay, this is your base, and what will base do? Base will abstract the H plus. So if you see here, this is your hydrogen. This hydrogen is very acidic. Why? Because if you will see, this hydrogen is attached with this nitrogen, and this particular nitrogen is attached with 2 electron withdrawing group. So if this base will come and abstract the H plus, here negative charge will come, and that negative charge is highly stabilized by the resonance of this 2 double bond O. Okay. So here what will happen? This OH minus will come and will abstract the H plus. So what it, after that it will form? It will form this one. This one remains same. This one, and here N minus, and this K plus will come. And this is nothing but, this is called as N potassio, N, because one K plus is there, so N potassio phthalimide. Okay, N potassio phthalimide. And this N potassio phthalimide is act as a nucleophile. So I am writing here, this will act as a nucleophile towards alkyl halide. Because after that, after forming this nucleophile, we are going to take alkyl halide. Okay, after that we are going to take a alkyl halide. So our alkyl halide was CH3Br. Okay, and here this nucleophile is acting towards alkyl halide by SN2 mechanism, via SN2. Okay, so it's better to write here SN2. Okay, because this is a very heavy nucleophile, so it is going to attack from the back side, and then Br will remove. So this, when N minus will come and when it will attack to CH3, this Br will come out. So what will happen after that? Here your product will be something like this. You will see very carefully, this one remains same, and from this nitrogen your CH3 is going to attach, and this K plus and Br minus, if you see here, delta positive here and delta negative, so K plus and Br minus, Kbr will form. Till right now here you form this one. Okay, this is called as N-methyl, very important again, N-methyl, and again this is structure your phthalimide, so you will call it as N-methyl phthalimide. N-methyl phthalimide. Okay, Right now, after that, first we take KOH, second we will take alkyl halide. The third one is the hydrolysis of this two imide bond. We have two imide bond. So what will happen when you will do the hydrolysis? Right now I will do the hydrolysis by taking H2H plus here. So if you see here, right now we have H2H plus in acidic medium. So what will happen? If you see very carefully, this particular nitrogen has lone pair. So first it will protonate, means this nitrogen lone pair will going to take H plus. So here what will happen here? If you see very carefully, look at here, double bond O, and here N positive, and here H will form. Okay, and this CH3 will remain same. Right now you have used already H plus. Right now you have water, means OH minus you have. That OH minus will come and going to attack on this carbonyl group, and this will open. Again O negative will come. So it's better to write here so that you will get very easily. Look here, if you will see, this OH minus is going to attack on this carbon. So here O negative will come and OH will come. Okay, this bond will remain intact, same, NHCH3, and this will also remain same. This amine bond is going to attach it here. Right now, what will happen here? This negative charge will come inside and break this particular bond, and it will neutralize the whatever the charge on negative charge is there. Okay, sorry, positive charge is there. So if you see very carefully, what will you get after that? You will get this one, and again this will going to restore, means this is going to again your double bond O. Okay, and this OH will remain same attached with this carbonyl carbon, and here if you will see, this will be double bond O, and here NHCH3 you will write, NHCH3. Again this nitro, because if you will see, the positive charge has been neutralized. So here one lone pair is remains there. Again you will do the hydrolysis here. You have H2 and H plus. So again this nitrogen will take the H plus. So what will happen again here? You will see very carefully. Double bond O, OH, and this will double bond O, and again here NH, and here again one H will come, this H, and here positive charge will come, and this CH3 will remain same. Again what will you have? You have OH minus. OH minus will come, and where will it attack? It will attack on this carbonyl group. Again negative charge will come. This negative charge will go inside and it will neutralize this, and it will coming out. The whole NH2CH3 will come out. So what will be your reaction product here? So this will going to be your OH. You will get a very beautiful product here, CH3NH2, and the byproduct will be your phthalic acid. So if you see very carefully, this will remain coming outside, means this whole will coming outside, and it will be NH2CH3. This is your 1 degree amine, methyl amine. So what we saw in this Gabriel synthesis, that if you will take a phthalimide here, that phthalimide will do acid base reaction. From that acid base reaction, we are going to prepare one nucleophile, very good nucleophile, and that nucleophile is going to attack on your alkyl halide. I am taking here CH3Br, and from that you will get a methyl phthalimide, and that methyl phthalimide, after that you will, if you will do the hydrolysis, 2 times hydrolysis you have to do, because here you have, if you will see, 2 imide bond, and I already told that what is imide. Imide is nothing but, you know, NH3. Okay, when your 2 hydrogen is replaced by these 2 carbonyls group, then it is called as imide, as you can see here. One question is coming in your mind, sir, you told that you can do the hydrolysis by taking N2H4 also. Yes, and that N2H4 will give you more better product than this one, more better yield. If you want to get as 1 degree amine, then it's better to do the hydrolysis with N2H4. So how will we do? Let us see from here only. I'm not going to do all the derivation, because when generally if you will see in the books also, they will show this water doing the hydrolysis by taking H2 and H plus. But if you take N2H4, you know that N2H4 here. So I am writing here N2H4. Okay, it means 2 nitrogen and 4 hydrogen. But you need 2 hydrogen only to form amine. So just write here H. Here also write H, and here write NH. Here also write NH. So if you see very carefully, here you are getting here N2H4. N 2 hydrogen means NH2 and this CH3. Look, you are getting same product, but the byproduct will remain change. Here you are getting phthalic acid. This is called as phthalic acid. Okay, but here when you will take hydrazine, you will get different byproduct. They can ask in examination, so be careful about that. So you will get double bond O. Here you have NH, so you will also write NH. Then single bond, then again you have NH, so let's write NH. Double bond O NH, and this structure is called as thalahydrazide. So this is nothing but thalahydrazide. Okay, thalahydrazide. So this is all about your reaction mechanism, how the product is going to form. Right now, just quickly see 3 questions and then we will wrap up this session. I hope everyone noted till this point. Yeah, see. First question, I will write some IUPAC name here, and you have to tell that either you can prepare by Gabriel synthesis or not. Okay, so you have to tell either it can be prepared by Gabriel synthesis or not. So here N butyl amine. The second question is, let's say here aniline. The third question is that, let's say I am taking here CH2 CH3, sorry, CH2 NH2. The fourth is CH2 NH CH3. The fifth one is this one. The sixth one is this one. The seventh one is, let's say, this one. My question is that I have written here 7th IUPAC name here and all are amine. So which amine can be prepared by Gabriel synthesis? This type of question has been already asked in your JMNC examination. Okay, so be careful about that. So if you will see here N-butylamine. So what is butylamine? N-butylamine. So the structure is something like this. And here if you will see, you are getting 1 degree amine. Okay. So what I told in Gabriel synthesis that you will prepare 1 degree amine, no doubt. So yes, you can prepare this one without any doubt. Okay. Because as you saw in the when we are solving the mechanism, it was following the SN2 mechanism. So what you need to keep in this mind that where the SN2 mechanism is going to take place. If you see this one, this will not. Aryl halide do not undergo SN2 mechanism or any not any. It's better to say it will not go through the SN1 and SN2 because aryl halide also show nucleophilic substitution. But when your aryl halide have, let's say, electron withdrawing group is attached on the para position, then it will show SNAR. Okay, but right now here if someone will ask, will aryl halide from, can you prepare arylamine from aryl halide via Gabriel synthesis? Then no. Why? Because they do not undergo nucleophilic substitution. So very one important point we should add that aryl halide will not converted to aryl amine via Gabriel synthesis because they do not undergo nucleophilic substitution reaction. So very important. Okay, so this will not show, aniline will not show. Okay, here if you will see this one, again you are getting 1 degree amine, this will show. If you will see this one, here you are getting secondary amine, so this will not show Gabriel, means you cannot prepare this amine by Gabriel synthesis. If you will see this one, here you can see NH2, but do you know how this will form? When you will take tertiary butyl bromide, when you will take this one, But do you really think if you will take this alkyl bromide will go through SN2? No, because here a bulky group is there. So it will not go through that and it will not form. Although it is 1 degree amine, but you cannot prepare. So very important thing which you need to keep in this mind, that if you will take this alkyl bromide, will it go through SN2? No. So it will not. Again, if you will see, again one bulky group is there. This is called as neopentylamine. This is called a tertiary butylamine. So this will not show. Very carefully. If you will see this one, this is isobutylamine. Isobutyl, because if you see CH3 position in this one and NH2. So isobutyl. I mean, yes, this will show. No issue, because if you want this one, then you need to take this one as your you need to take this one as your alkyl halide, and again yes, this will show, because here 1 degree it can easily attack and Br minus will get out and you will get this one after hydrolysis. So yes, this will form. So this type of question can be asked. One set of question. Let us see the second set of question here. The second set of question, in that let's say they can ask like if you see for example, if I will take this one, here I am forming NH2, I am taking Br, and here I am taking your N minus K plus, means N potassiothalamide, plus I am saying that here you have a compound A, and that compound A is your alkyl halide. Then you need to tell what is the alkyl halide here. The question is that, listen very carefully, this is the product, this is the substrate basically, N potassiothalamide. Your N potassiothalamide is react with which alkyl halide, so that you will get this one as your product. Okay, so very important, nothing too much in this question. What you need to think that which alkyl halide you will take. So it's very simple. You will take, if you will replace this one and you will attach any halide group, it's better to take Br, or you can take Cl as well. Okay, so the answer will be this one, this one, this one, and this one remains. Not to write a whole thing, you just have to focus on the product, because you have to, they just ask what will be the alkyl halide. If this one will be your substrate, then which alkyl halide will give this one. Okay, so if you will see, one carbon is there, so just attach, and from that any alkyl halide you can attach here. Let's say Cl, Br, but better if you can take Br here, and this will remain same, nothing to do. So this will be your alkyl halide, because if you will take this alkyl halide now, what will happen? This N minus will come and attack on this carbon, this Br will get out. Okay, and this N will attach with this, and after hydrolysis you will get this one. Okay, this was the second set of question. The last set of question is that I am giving you a reaction here. Let's say you have a S2 octanol, okay, which are going to react with paratoluene sulfonyl group, S double bond O Cl, in the presence of pyridine. Okay, so you are getting product A. After that, whatever the product A you will get, that is going to react with sodium azide in the presence of methanol. Okay, so you will get product B. So when you will get product B, this is going to react with LiAlH4 in the presence of water, and it will form C. So you need to tell what will be the product C. Okay, so let us see. Please try everyone and check the answer. So you have a 2 octanol. So just make octanol structure 1, 2, 3, 4, 5, 6, 7, 8, and you have OH group is present on the second carbon. So just make here OH. Okay, and hydrogen is there. Okay, so if you will see here the configuration of this carbon, that will be S. You can check, as you know from your GOC and all basic. So this is your 2 octanol. Okay, S2 octanol, because configuration is also mentioned. So if you are writing the board examination or subjective examination, so you need to be very specific that you have to make S. Okay, so you know this all thing. So what will happen here? This particular oxygen has lone pair. This lone pair will go, and this particular sulfur has vacant orbital. Vacant d orbital is there. So it will attack on this one. So what will happen? This double bond O will open, and here negative charge will come. This negative charge again push inward, and this Cl is minus is a very good leaving group. It is going outside. So a very beautiful product you will get. This one, 1, 2. I am just writing this whole product as R dash because I am not going to write again and again and again same thing. So I am just writing R dash here. CH3 will remain same. Here O, and this lone pair is going to attack on this particular sulfur. So positive charge will